In this video, we're going to start creating our player, which means we'll have to import our player mesh, get our player game object all set up, and yeah, get ready to actually start coding in our movement and camera code.
That means spaceships, and that means fun.
Yes, indeed it does. So let's start off with creating our player game object. So I'm going to go to game object, and I'm going to create an empty, and I'm going to call it player. Then I'm going to position it at 0, 0, 0. So what I'm going to do is I'm actually going to create the mesh as a child object of our player game object, and that gives us more control over the way that we want that mesh to be positioned with its pivot point and the way that it's going to be oriented. Because in this particular game, we're going to be assuming that the player's forward direction is along the positive z-axis. So we want to make sure that when we import our mesh, we can create it as a child of our player and get it all set up and offsetted correctly so that our math becomes simpler. So this is a common technique that I use quite often. The first step, though, is that we do need to go ahead and grab our player mesh. So our player mesh is going to be included in our assets folder, which I have right here. So I'm going to zoom out here to get to our details view. And we're going to bring in Fighter01 FBX. So I'm going to move this off to the side. I'm going to create a new folder called Models. And I'm going to simply drag and drop our Fighter01 into our Models folder. And then wait a year.
Now, as this project grows, do you want subfolders in there? Because ultimately this will have quite a few models involved.
Yeah and no. It just depends on how the organizational structure makes sense as the project continues to grow.
Okay.
Now, the FBX file did actually include our specular and... come on, seriously? There we go. It did include a bunch of stuff that we don't want to deal with, honestly. And there's actually cry animation export node. Huh. Anyway, it included a
That shouldn't have been there.
It included a diffuse texture, a normal texture, and a specular texture. However, I did actually get a different set of diffuse and normal textures after the fact. So we are effectively just going to be removing these out of our project. I'm going to close that out or delete all of these guys. And I'm going to create a subfolder called Fighter01. I'm also going to remove the materials. And then I'm going to bring our new updated diffuse and normal maps into my Fighter1 subfolder. And then I'm going to create a new material called Fighter01. So I am organizing it in the way that that I find common, with the mesh being next to a folder that contains the material that's going to be used. So I'm not actually going to use this prefab. I'm going to ignore this prefab entirely. Instead, what I'm going to do is I'm going to construct our game object manually by using additional components with our render and our colliders and our filter. And I do that to retain additional flexibility over what Unity offers with the built-in prefab. So first of all, I'm not going to configure my material just yet because I want to see my fighter in the scene. So I'm double-click on player, and then I'm going to say game object create empty, and I'm going to child it to player, and I'm going to call it mesh. With mesh, I'm going to add a mesh filter, which I'm going to hit this little target button, and we see that we have human fighter low. So that's what we'll be using for our mesh filter. Next up, I'll add a mesh renderer. And now we can see it kind of sort of trying to be rendered right here, but we don't have a material associated with it quite yet. To fix that, I'm going to drag and drop my newly created Fighter01 material onto our mesh, and we get a nice diffuse on it. A nice diffuse texture, or a nice diffuse material with that texture on it. So as you can already see, it's already oriented incorrectly. Now, you can go through the trouble of making sure that everything is oriented correctly within the modeling application you choose. But again, I find that you retain a lot more flexibility by having the mesh be a child of your game object, so you can orient it in whatever direction that you want. Now, in this case, I said that I wanted the player to face the positive Z direction. So to do that, I'm going to go ahead and set its rotation to 270 and 270 in the X and the Y. That will orient it along the positive X axis. So now we have done that, let's go ahead and jump into our material and go ahead and configure it with our diffuse and normal maps. So the shader that I'm going to be using is actually going to be our bumped specular. So our bumped specular will allow us to supply a base texture and a normal map. Now it's important to understand that the base texture actually includes a specular map in the A channel. You can see that kind of represented right here. It says base RGB gloss A. That means the alpha channel is going to be used to determine the specularity of this model as it's rendered, which has already been all set up for us.
And if anybody does want to mess with their own models, that's as easy as creating your specular map, Control A, copy, and just create a new alpha channel and paste it in, and you're done. It's very simple.
Yep. So now all I have to do is I'm going to click and drag my diffuse texture onto this, and we get our specular map and our normal diffuse texture applied to it. And then I'm going to do the same thing with the normal map. Now, when I bring the normal map on top of it, it's going to say this texture is not marked as a normal map. You have to mark textures as a normal map in the import settings in order for them to work properly with these shaders. Fortunately, Unity provides us this Fix Now button that we can use. So I say Fix Now, and now we have a basic texture, we have a normal map, and we have a specular map applied to this.
Sweet.
Okay, so now I'm going to go ahead and scale it down just a little bit. So I'm going to select the mesh, not the player. Now the player is going to be at the origin. That's important because that allows us to manipulate the player as if it was positioned, oriented, and scaled in this by the modeling application. So I'm going to go down to the mesh and I'm going to scale that. I'm going to bring it down to 0.4, 0.4, 0.4. That just is a particular value that I found worked well with the other assets in the scene and the way I wanted to do the math.
And that stuff usually just comes down to experiment a little bit.
Right, yep. And by doing it this way, by having the mesh parent or childed, parented, whichever one, to the player, we can manipulate this mesh independently of our player.
Nice.
Okay, so the next thing I want to do is I want to create a box. And the reason I'm going to do that is because the player is going to have a spotlight attached to the front of his ship. And that's a nice little effect that will sort of not just look cool, but also allow us to kind of see where our ship is pointing at when we are in the asteroid field. It's just a nice little visual cue. So to do that, I'm going to create a box just so we can test our spotlight. So this box is going to be eventually deleted, but I just want it there so we can see how our spotlight looks. So next up, I'm going to go to Game Object, Create Other, and I'm going to create a spotlight, and I'm going to place it on our player. Now, I need to go ahead and orient the spotlight to be coming out of the front of the ship, which should be easy to do. I'm going to set its position to 0, 0, 0. Then I'm going to move it up a little bit. I'm going to eyeball this right to the nose of the ship. I'm going to clear out the X axis. Then I'm going to look down this axis so I can get the rotation correct, and maybe move it down just a little bit. So now it looks like our cone is coming out of our player. Next up, I'm going to put in some values that I've already figured out through trial and error, which is pretty much the epitome of configuring things like lighting.
Or anything else in a game engine.
Yeah. I'm going to give it a range of 30 units. I'm going to give it a, give it the intensity of 1.8. I'm going to give the color a bit of a reddish hue to it. Now we're not seeing this. Yeah, there we go. It's because it's so intense at that level, but that's fine. If I go ahead and make this bigger, we can kind of see what's going on with that spotlight. And as it goes bigger, it goes like that. As far as the spot angle, let's leave that at 30, or maybe I can widen that just a tad. You can play with this all day.
Now, I would have thought the color would have changed the whole thing, but it's kind of given a halo effect. Is that because of the intensity we set it at?
Yeah, once it gets to so close to the player, it will effectively turn to white. But that's fine because in practice, you rarely get close enough to things for it to have that appearance. The last thing that I want to go ahead and do is I want, or at least as far as our spotlight is concerned, I want to add a cookie to it. Now, a cookie is a cool little cutout of our spotlight that makes it look like it's being projected out of a particular object, such as a flashlight. So what do I mean by that? Well, I'm going to go into Assets, Import Package, and I'm going to bring in light cookies. And that's going to bring in our light cookies, our flashlight are regular, hard, soft, and square. I'm just going to bring in all of these. That'll create a nice little standard assets folder with our light cookies in it. And then to apply this, I'm going to go into my directional light, my spotlight, and I'm going to go down to his cookie, and I'm going to select flashlight. Now that I've selected...
Oh, that's neat.
Yeah, so now that I've selected the flashlight cookie, we see that it's kind of like this little cutout type effect that gives it a nice little flashlight effect.
Yeah, that's very cool.
So anyway, stuff that you can just play around with for days and days and days to make things look the way you want them to, but I'm just showing you guys all the different options you have with doing stuff like this. Now, it's important to understand that because the spotlight is a child of player, as we move the player around, so does the spotlight moves as well, which is the effect that we want. So let's go ahead and position him out into 0, 0, 0. Okay, so there's two more things we need to do. We need to create our mesh collider, and we need to create our rigid body. Now, in Unity, we have a physics engine that we can use to great effect to do lots of fun stuff. That being said, with this particular game, we aren't going to be using a whole lot of advanced physics or a lot of the built-in physics stuff because, well, honestly, if you were trying to build like a realistic space simulator or something like that, you would definitely want to take advantage of this stuff. But because we're going for a more arcadey style game, we're going to be ignoring a lot of the physics stuff that Unity provides us, such as, well, gravity, obviously, because we're in space, but also things like how forces are applied to particular points on a mesh. But it's cool, though, that we are able to actually effectively disable those features and just use the ones we want in order to do things like detect collisions with other objects. Now, we'll talk a whole lot more about collisions later, and you can find some really good documentation online about how they work. But in order for an object to collide with another object, we have to attach a rigid body to it. And we have to attach a collider to it. With those two components, it's able to be collided with other objects in our game, and we're able to be notified of those collisions, and we'll have super lots of fun. Super lots of fun. You know what I'm trying to say.
Yeah, super lots of fun.
Super lots
we
of
have
fun.
that all the time.
Oh, yeah. So let's go ahead and jump into our mesh, or mesh component anyway. And I'll hit add component. And the first one I'm going to do is add a rigid body. Now, if I add the rigid body, we see we have a lot of options such as mass, drag, angular drag, gravity, kinematic, interpolate, collision detection, and constraints. If we leave all these by default, watch what happens when I hit play.
The gravity that we shouldn't have in space grabbed it.
Yeah. So let's start off with disabling gravity. Now, the next thing I want to do is I want to check is kinematic. Now, is kinematic effectively releases control of our rigid body from Unity's physics engine and allows us to do the calculations manually. Now, since we are building a very arcadey style game, those calculations are very straightforward and are a lot more straightforward than trying to play with the force API of a rigid body. So we're going to check is kinematic to make sure we have full control over the position, rotation, velocity of our object. As far as interpolate and collision detection, we'll leave those as default. Next thing I'm going to do is I'm going to add another component, and this is going to be our mesh collider. So I'm simply going to say mesh collider, and I am going to set is trigger. Now, the reason I'm doing that is, again, since we're ignoring a lot of the built-in physics of Unity, we don't want to be given information such as the force one object hit another object with. In fact, in order to have those calculations given to us, we would have to play around with the is kinematic and, well, effectively turn it off and have Unity handle those calculations for us. Since we're doing those calculations ourselves, we want to essentially only be notified if our object collides with another object. We don't need to be notified about what point that object collided with the other object. We don't need to be notified about the force or the mass or the drag or anything like that. So instead, we're going to be using triggers.
Yeah, that way we get just this hit this and that's it.
Right. And since that's all we need, we're going to set is trigger to true. So I think that pretty much wraps up our player. There's not a whole lot more to do as far as our player's game object is concerned, and the next bits that we're going to be playing with is going to be the actual code that controls our player and allows it to move around the scene. So with that, we will see you guys in the next video.
Great.
After we commit.
Ah, yes.
See, I almost forgot it myself. At index, let's go ahead and hit commit and say video for player part 1. Hit commit, and everything is good.